Welcome to studentstest.com. The topic is rules for block diagram reduction. Now we can reduce the block diagram in a simplified form. If the block diagram is very much complicated, then it will be difficult to understand it. So we can reduce it and can simplify it by using these rules. The rule number one is associative law. This is a simple block diagram which is given to us. These are the two summing points and these are the inputs. The input 1 is going into the addition sign and the input 2 is negative and the input 3 is also positive, and then there is an output. How to make an equation by this block diagram? Since R1 is going into the positive sign, so R1 is positive, and R2 is going into negative, so minus of R2, and then R3 is positive again, so plus R3. If we change the summing signs, means if over here there is R3 and in the negative sign there is R2, then what will happen? Let's see. So we have just changed the summing points. Now R3 is positive and over here, and R2 is negative and over here. And now we make an equation. So R1 is positive and R3 is positive now, and minus of R2 because R2 is negative. So this value and this equation is not identical, means if we change the summing points or signs, then the output will not be the same, and this is what associative law explains. The rule number 2 is for blocks in series or cascade. This is the simple block diagram which is given to us. Over here G1, G2, G3 are individual gains. Now let's make an equation. For R1 is equivalent to G1 into R, for R2 G2 into R1, and for output G3 into R2. Now by the formula of transfer function, it will be G1 of S, G2 of S, G3 of S. So we can simplify this into this form because this and this are identicals, and we have proved it by the transfer function. So we can reduce this one into this one. And this is what for blocks in cascade rule explains. The rule number 3 is for blocks in parallel. But before moving on to that topic, let's solve this question. The question is determine the transfer function of the block diagram shown below. I have taken this question from the book Control Systems by Samarjit Ghosh. Just write the values of the input which is given to us and then perform the LCM, and after performing the LCM and simplifying it, you will get 100 s plus 3 s plus 1 s plus 2 s plus 4, which is the transfer function of this block diagram. Now let's move towards the rule number 3, which is blocks in parallel. Now these are the blocks which is given to us. This is the block diagram which is given to us and it is parallel. Now how to make an equation in parallel? G1 of S is going into plus and R2 is going into negative and R3 is going into positive. So G1 into R1 minus G2 into R2 and plus, because plus is going into positive, so plus G3 into R3. Now by using the transfer function, G1 of S minus G2 of S plus G3 of S. So we can reduce this typical diagram into this simple diagram by just writing this equation into it, which we have proved by the transfer function. And this is what blocks in parallel rule explains. Let's solve a simple question. Determine the ratio of transfer function of the block diagram of the following block diagram. Now over here, all the values, all the inputs are going into the positive summing point, and then there is an output. So it is very easy to make an equation from this. Now 1 divided by S plus, because R2 is also going into negative positive sign, so plus 2 divided by S plus 1. Plus 3 divided by S plus 3, because this is also going into the positive summing point. Simplify it and you will get this. This is what rule number 3 explains. Thank you very much for watching the video.